Oh, Angela, your love for nature makes me sad. Well, if you live in any kind of European country that's a part of European Union, you will no longer buy 2000 watt vacuum anywhere. It's not possible anymore, and because German oppression here in Europe continues, and we currently are unable to buy a proper vacuum that will actually suck the dirt and stuff, and well, we still have to rely on the old models. So here we are, and okay, so this is my vacuum. I used it. This was serviced. I used it as a second hand, but also serviced. So there is a board here with I think triac to regulate this. But well, why would you need to regulate the flow on your vacuum cleaner? I mean, I don't get it. You don't want to you don't want to clean up the dirt. You just want to be annoyed by the vacuum and move it around and so on. I don't really get it. This is how you reduce the suck factor in a vacuum cleaner, not using fancy electronics. So European Union just glue this knob on the minimum, and you have now 1600 watts max vacuum cleaners. So that's really bad. And what we are going to do today is to fix this, because the triac, I think, it blew out and it no longer works. I had to do a quick fix inside there and connect the motor directly. So every time you put this into a socket, it will start. And this is AC motor here. I took it apart some time ago, did some servicing. This particular vacuum has, I think, 7 years. At least it's 5 years in my hands, and I clean up all kinds of dirt. The dirt after sanding walls, I'm not sure how well, the dry walls, and well, I almost broke the motor because the fine particles got inside of it, and I had to clean it up. We will be cleaning the motor. We will be adding a switch, as you can see here. Hey, painted black. I mean, you don't really need a proper nice switch there. One thing, this is rated 60 amps, but not sure if you can see. Yeah, 60 amps, 250 volts. And it disconnects two phases, so it's perfect for us. But, I mean two lines. Well, for the motor, you don't really, you shouldn't use a chintzy switch like that, because the load, I mean the initial load and disconnection, it will probably arc inside. It arcs when I disconnect this from the outlet. So well, we will see. After some time, the contacts on the switch may weld together, but well, this is a vacuum, right? I'm not really that worried about this, and well, if this will weld together, I will simply disconnect it from the outlet and I'll be fine. So well, what you would be looking for if you are buying a proper switch for a motor is to look anywhere if it's rated to run any kind of it will do to know that it should be running a motor. You will have a horsepower rating here, and if it's actually 2000, then you will have something like 2.5 horsepower. I think there is something like 700 something watts per horsepower. So let's check it out. Let's see what's the actual rating of this stuff, and we will be using a kilowatt, cheapest one available, and some crappy outlets. Don't worry, this is not rated for over 10 amps, but well, I don't really care. You just have to work with what you have, right? Well, sure enough, 2.68 horsepower if this is actually rated 2 kilowatts. And let's see, let's just connect it to the outlet. Just let me turn this thing on. Select, the watts are selected. Hopefully you can see it will be displayed over here. And we will check it out. Let's see if it will run any better without any load. Let's just see. So, well, they didn't lie, at least. Well, and something like 2 kilowatts, even though this motor has something like 7 years, 7, 8 probably. So let's take it apart, look inside. I will show you how craptacular I fix this back together, because this no longer works. And let's check it out. It's only held by 5 screws. This will reel in because there is no load on this over here. Well, it's really dirty, and sorry about that, but that's the reason why I'm taking it apart, to clean it and make it useful again. As you can see here, well, let's see. Hey, it took a bite. I mean, this heats up when it's running. Okay, I simply connected the motor directly, and well, we don't need this port anymore. Let me just see if I can take it out without any. Oh, I want to keep this here. I don't want this button to spring, but oh, it will hold. It's pretty nice without the bolt. Okay, we will just glue this, and as you can see, I connected the motor directly. Just did a craptacular job because I wanted to finish vacuuming. It all heated up because this is not really rated for that kind of stuff, and this may be also the reason why we didn't have full 2 kilowatts. But well, yeah, this really heats up. It's just held by electrician tape, and I will cut those leads and solder them properly to our contacts on the switch. And we have a nice space here. We may be able to put the switch there. I was kind of worried because, as you can see here on the ABS plastic, the top half is the most part of the construction, and I will be able to cut out the rectangle for a switch, and we will be golden. Well, you can always kick the vacuum cleaner to turn it on or off. Perfect. The one thing they probably, because I saw a newer iteration of this vacuum, they decided on a matte finish of the plastic. Well, they probably saw something like this, because this is always dirty. I mean, you should never have a glossy finish on well, basically a cleaning tool. Let's see how to disconnect this. Crappy knife for crappy solutions. Okay, it's really crusty. I mean, I think it's starting to burn there because I see some shit stains, right? Okay, let's remove this. Well, this burned right through. I won't be salvaging this connector anymore, so let me just cut it, because I don't really care that much about it. Okay, one at a time. Perfect. And this one too. Okay, that's nice. Let's see, or maybe I could put a switch over here, but well, that's at the. I'm not sure if it will fit. Something like that. No. Nah, that's a bad idea. Okay, let's take the motor out. Oh, this is getting really hot. There are some not stakes, but they simply cramp this inside. I already took this apart. I will have to clean it up, and I will remove the brushes and grease this stuff a bit. Of course, clean this up. I think there is a bearing there, or maybe a bushing only, maybe a bearing, and I will try to get into it and check it out. But let me just take this cover first. Well, this is a standard motor. You can buy this. There is even a number over here. Yeah, see? Okay, so we have our motor here. Let me just take out the brushes first. Okay. To be honest, I put everything into a bathtub and gave it a nice warm shower, so it's really wet. Don't plug with electronics to the wall, but if you dry them out, go ahead. So, all the brushes seems pretty nice. I mean, they're fine. No signs of, well, a lot of wear. They're kind of dirty, but I will be greasing them a bit. For any grease action, I will use this Tavot. That's a grease that was invented, I think, by a Russian guy named Tavot. As we say here, when Russian guy invents something, they probably did it on a German attic when they broke in. And as you can see here, it works from -25 to plus 125 Celsius degrees. So we are pretty fine. It shouldn't work hotter than that. I think I saw something like 80 degrees max on this. Inside, I mean. It would be nice to remove the screw. I will try it. There is a bit of Loctite in there, and I will try to clean this up. Also, I will try to clean up this, because as you can see or not, it's pretty dirty inside. And for that, I will be using this, well, my bedside toothbrush. Well, not everyone keeps the toothbrush near you when you sleep, but well, it's really useful if you have to clean it and get it really in there really well. It won't get any dirty, right? I wasn't able to remove this screw. If I hold this and try to spin this part, aluminium part, then this simply spins and this stays in place. So it's just friction fit in there, and I think it's not even staked on. I removed the connectors to clean I'll clean this with a sandpaper, and what I also removed is this thermal fuse. You should be able to see it. One side is connected to this side is connected to the packaging, and the other side is in this foil, but there is probably a connection in between there. So in the moment when this heats up really well, you probably will be able to find a data sheet on that, but well, I don't care at the moment. If it's not blown, why should I look it up? And well, this will There are two types of thermal fuses. Those that will go back and connect again when there is a lower temperature, and those that will break. And well, I think this should be the first type. I'm not sure. I wanted to replace the cables, but well, they're pretty tightly made here, so I will just extend those cords later on to connect the switch. You should crimp the connectors really well with using any measures, because 2 kilowatts, it's a lot of it's a lot of angry electrons, so you don't want to have this moving around. This should keep a nice stiff connection. Believe it or not, I was thinking, and all this sentence could make a video on its own, but well, I don't see a start or run capacitor on this. I'm not sure why. This is AC motor basically. Quick correction here, this is an universal motor, and it's adapted to work with AC better, and I will put a link in the description describing how it actually works. So it works better on the AC. The universal motor works well on the DC, also well as on the AC. And what I also wanted to mention, that it doesn't matter the frequency that you run the universal motor, but you have to keep the voltage at 220 or something like that volts or more. And the reason is that if you run it at 110 volts, like in US or Japan or something like that, well then the wire gauge on the motor windings is not thick enough, so it will probably burn out the wires. I was checking, and this is actually made by Samsung, this model. Hello? Okay, this model. This is actually made by Samsung, and this class F. This is really nice because it's maximal temperature, that is the thermal properties of this motor. Its maximal run temperature is 155 Celsius, and its normal temperature that won't decrease its lifespan is I think 105. So that's pretty good. You can look it up online, and there will be a table. If anyone wonders why I won't use this switch in my assembly, it's because the first thing is that you are not able to see when it's disconnected from the socket, if it's on or off on the outside, because there is a spring that shows it's basically always off. It looks like it's always off, and no one likes to plug in the vacuum and to notice that it was on all the time, and you are 5 meters in the other direction. But the second part is, I think I will be able to show you. See here, it's rating, well, the half horsepower. So this is not really rated to turn on whole motor on its own. I think somewhere here is 10 or 8 amps. Yeah, it says something like that. And this is not really made to turn, and it will be only switching single side, let's say, because this is only a mounting hole, and it only connects these 2 points. So it's not really a good idea. I feel much safer disconnecting both wires. Okay, let's put some grease inside of it, and some on the bearing, just for good luck. Hopefully it will prevent any ingress of the moisture. I will smear it in a moment, and well, this doesn't move, so I guess I will put it some here just to, well, that's just for me, to feel better. It's also a good idea to put some grease inside brush holders. You want to this to move nice and smoothly, so it won't wear the brushes on those sides. And only this grease, in the case it will come into contact with the rotor, it will just burn out. It will smell a little, but don't worry about it. Okay, after removing the electronics, it's time to put something in this hole that was for cooling, and you would be much better using something else, but I guess the hot glue would do the job same way, just on both sides, so it will be nice and sticky there. I did some reading, and this glue will come apart in 120 degrees, and this slot is for cooling the IC chip, so I'm not worried about this going apart. Or we can put the motor back together with some percussive maintenance, and just make sure that it's bent a little so it won't fall apart. When you are putting this together, rubber shoes are very important, and I will show you a way how to make this vacuum, and probably yours too, suck a little better. Just make sure when the power is needed, it has a bit more power, sucking power, because there is a vacuum basically valve that's placed here. I use some electrician tape just to make sure that it seals better, and use some foam on the plastic right here, so it will seal this valve better. Because what happens when you put the vacuum cleaner to something that it sticks to, this vacuum valve will open, and it will it basically will stop sucking on your side as much, and that's not ideal. You can use also, what I will also do, I will use some more electrician's tape, and just make sure that it doesn't have as much airflow on it, so it won't open so often so basically I will have actually put the end of the vacuum cleaner to something that will stick it to it permanently, so and after that only this will open. But it will clean more debris easier, and this way this vacuum will work actually better. To connect those two, I will be using lineman splice. How it works, it's you connect, you fold them like so, and again you go over and just do something like that. So you have a nice, this will break on this side and on this side after I will solder this, but it won't break on the connection point. All NASA connects this using the lineman splice, so it's good enough for our old vacuum, right? The important thing is to solder this properly, and first I will heat it up and then apply some solder. I did a much better job on the other lineman splice connection. After soldering the lineman splice, it's time to put a heat shrink on it so it will stop looking ugly, like my ones. And let me just use this lighter to crimp it. And well, you are done. I'm done extending the cables. And I will be able to connect now the switch. After thinning wires and cutting them to the size so the conductor won't stick out too much, I will connect them to the switch, but I will also measure this, so I will be making a nice hole for the switch on the other part, the cover for the vacuum. 27 by 23, 28, 23, something like that. So I want to have this like so, and well, this would be even better because, okay, so this is off, this is on, perfect. I mean, you know, it's off, you just put a foot onto it, it's on, and you actually have to press it to turn it off. So that's a good idea. I made the hole, it's not the prettiest, but the switch will fit just fine, and there is a frame, so it will cover the roughness and the edges. Now what I need to do is simply connect a brown to brown and blue to blue using the switch. Alright, I can put this back together, just make sure that this sticks out a bit. This will be the top. And let's screw this in before putting the switch inside. Okay, that's the last fastener, and I can now put the switch inside. It clicked, perfect. For a shitty old vacuum, it's pretty good. This is on, this is off. Let's try it out. Oh, hopefully this won't set on fire. Okay, so far so good. Let me switch to watts. These are watts. Nothing at the moment. Pretty good. It even got to 2.1 kilowatt. The reason for that may be the grease on the brushes didn't wear off yet or something like that, but eventually it will. And this is a bit smelly right now because of the grease, and it will wear off. It will, the brushes will clean itself on the surface, and it will work just fine. Let's put the filters back in and check again. Okay, that's done. And let's test it out. I'm curious about the I can put it over here so you can see better the power factor, how it will look. But also I noticed that it took 3.5 kilowatts at the start. I'm curious also how high this can get. Right, that's pretty nice. So even up to 5 and more kilowatts at the start. That's the this is what you get when you don't have a capacitor in your appliance. But the weird thing was, because this is untypical, this is a inductive load, so almost 1 unity power factor. That's kind of weird, but well, that's good. This is how you can find the operation of the European Union or similar situations. You need to learn how to keep your stuff in a good shape, so you wouldn't have to replace it, just like your car or other things, and you wouldn't have to spend additional money, and just this simple maintenance and getting rid of this dumb power button that you never knew if it was on or off. It's really nice. At least now I know exactly when it's on, when it's off. There will be a lot of sparking inside of this. That's why I didn't want to have to plug it in to the mains directly. It's always better if it's contained somewhere. That's it. I hope you enjoyed this video. Thanks for watching. It's time for me to clean up all this mess around. Maybe do some vacuuming.